So this situation is very similar to what we were looking at yesterday. In that previous lesson, we had two secants that were intersecting each other outside the circle. Here we have a tangent, EF is tangent to the circle, and a secant, HF, that are meeting out here at a point outside the circle. So the idea for this formula or rule is the same, that we're taking the outer portion times the entire portion of the segment. However, for a tangent, those two things are equal to each other. The portion of the segment outside the circle is EF, which is also the entire segment. So the way we would set this up, very similar. I would do 4 times 4 plus x. 4 plus x is representing the entire length of FH. And that would be equal to the outer part, which is 10 times 10. So I'm really going to be squaring the value of the length of the tangent segment. So let's go ahead and complete this. If I distribute the 4 times 4 is 16. 4 times x is 4x. So 16 plus 4x equals 10 times 10 is 100. So I'm going to go through and isolate x. The first step to do that is to subtract 16 from both sides. When I do that, the 16s cancel out here and only 4x remains. And when I do 100 minus 16, I get 84. Okay, so my final step to isolate x is to divide both sides by 4. On the left side, those 4's cancel each other out. On the right side, when I do 84 divided by 4, I get 21. So x is equal to 21. Looking back, making sure that seems logical based on the diagram. This length x, could it be 21? That seems reasonable. This length looks like it might be around double the length of EF, which is 10, so that seems to make sense here.